And here's the warm-up. So, suppose you start the origin movement on the x-axis. Oh my gosh. All right, what are the coordinates of your position if you go positive 5 on the x and negative 7 on the y? Sophie, what are your coordinates?
5, negative 7.
5, negative 7. Woo! Okay. Good. That's just a warm-up to see if you are ready for some math. All right. So today we are starting section 12.1, which I am entitling Space. And it's really to get you used to 3 dimensions, and we're going to learn about the 3-dimensional coordinate system. I'm going to close the door. Yeah, this lesson is a little mishmashed. In our old book, we started in with vectors and then moved into space. In our new book, we start with space first and then move into vectors. So I had to kind of do a little rearranging, but it should be fine. So we'll see how this goes. So first section of Calc 3. One thing I just want to point out to you that regardless of whatever book we're using, the whole first unit, there's almost no calculus at all in the first unit. I think I can say firmly that there is no calculus at all in the first unit. The entire first unit, all of chapter 12 in this book, which was chapter 11 in our previous book, is nothing but getting comfortable with vectors in space, and graphing in space, and all the stuff about working in 3 dimensions. The vast majority of calculus that we will have to do will be with vectors, and because of that, you have to get really comfortable using vectors. So that's how we do all of the movement in 3 dimensions. I don't know if you remember last year. Last year, when we would do our PVA, it was all linear, either horizontal or vertical, all the way until chapter 10, when we got to parametric, and then you would get like a dx dt for your horizontal motion and a dy dt for your vertical motion. So you would have, that allowed us to move in 2 dimensions. But the only way to do it was with vectors, right? So we're going to do the same thing now, having a dx dt, a dy dt, and a dz dt, right? We'll have 3 dimensions, and that way it's the same thing now, just with a 3rd dimension, right? But we got to get comfortable with all those 3-dimensional things. So no limits, no derivatives, no integrals this whole first unit. It's just vector stuff. So mostly it's like 3-dimensional pre-calculus, this first unit. All right, so let me get out. This is Mr. Thomas's. He handed this down to me. I know you can't see it on the screencast, but you get that lovely visual. I thought I had it so that I could pull this out. There we go. Okay. So you guys saw this in the room all year last year, and you probably knew what it was. I don't know if you knew what it was or not. So this is Mr. Thomas's representation of a 3-dimensional coordinate system using PVC piping. And so the colored lines are the axes. So I don't care which color goes with which axis. I'm going to let you guys right now as a class decide what color do you want the x-axis to be?
Red.
Okay. How many want yellow? Raise your hand. I think yellow was what I heard the most. I'm going to go with yellow. What color do you want the y-axis to be?
Red.
Red. So if x is yellow and y is red, am I holding this correctly?
Yes.
The answer would be no. This is now our 3-dimensional coordinate system. This is the way that we orient the axes in 3 dimensions. X comes out this way. Y goes across this way. And what's our new up and down? That's Z. That's Z. So what happens when you go into 3 dimensions is they've got to take the XY plane. So you take your XY plane, you don't just like go like that. You actually, I can't do it. It goes like that. So you have like X, you have Y, it goes like that. So X, Y. I can't my body doesn't work that way. That's what it does. So it's kind of like a turn and a twist that it does. So here, like this is a drawing from the internet, so like that, you can't really tell, but that's X, that's Y, that's Z. So your X comes out this way, your Y, and your X also goes behind too, you just can't see it, right? Your Y is going this way, and then your Z is always the up and down part. All right, so when you're looking at, there we go. When you're looking at your X, Y, Z plane, if we had to graph points, so when you graph a point, this is kind of tricky, and I'm going to give you a little happy news. You will never, ever be asked to graph anything on a quiz or a test. It is just really, really hard to graph in any way that's sensible in 3 dimensions by hand. The only person I've ever seen who could do it was Kashish. So if anyone knows her, she still goes here. She's a senior, right? She's amazing. Oh my goodness. You should like say you've heard about her 3D graphing abilities, because I've never seen anything like it. Like she had, I mean, shading, and it's just beautiful. Like she could, it was like it looked computer generated, the stuff that she had in her notebook. It was amazing. So anyway, I do not have that gift. So and I don't ask it of you, and neither did Mr. Thomas, just so you know, for the years that he taught this. It's just too hard. So I'm going to show you how it works, and I'm going to show you then how you can do it easily on your laptop so that you don't have to worry about doing it pencil and paper. All right, so if we have to graph a point, when you're looking at an ordered triple, so that's your X, Y, Z. So first thing we do is we graph the X. Now, your X isn't slanted like diagonally like this. You have to think of the X. So you'll note I have all these little tools. Now you'll know like what we use these for in Calc 3. Okay, the X-axis is actually coming out this way, right? So, whoops, stop. Okay, so there's the Y, there's the Z. The X is coming out of the board, but there's no way in 2 dimensions to graph a line coming out of the board. So instead, traditionally we graph it as this diagonal line, and you have to kind of adjust your sight and go, whoa, it's like it's coming out of the board. So anyway, so that's that diagonal line is the X-axis. So if we start by graphing the point 2, -5, 3, we start by going out 2, 1, 2 on the X-axis, right? So you go out 2 on the X. You don't go straight to -5 on the Y. You look at that -5 like, hey, there's -5, right? Except it doesn't work like that because it's not straight below the -5 that we draw. We have to actually go that distance from this point. So if this distance, let's say it's about that, we're going to go about to here. So, okay, so there's our 2 on the X, there's our -5 in the Y direction, and now we have to go up 3 in the Z direction. Well, Z equals 3, that's here. So we need to go up this distance, but from this spot. So we're going about there, maybe a little bit less. Okay, too high. All right, so that's our final point. So when you look at it, so you've got 2, this is 2, this is 5, this is 3, this is a point 2, -5, 3. So it's kind of funky because if I didn't have the lines and I just had the point, you'd look at it and you're like, how is that possibly 2, -5, 3, right? And the other problem when you look at this point, if there's no other lines and there's just the dot there, say I just drew that dot in at that spot and gave you no other information, could you tell me what point that is? There's no way. It could be infinitely many. Like there's so many different points that could land at what looks like that spot, right? So most people draw the little lines that get you there just so that it's kind of like a, hey, by the way, that's what this is. Some people even go further. Some people draw this. Getting there. I need to do this in different colors. There. So I'm going to do it without dots. I'm going to mess this up. I almost had it. Here we go. There. Ta-da! Except that shouldn't be there. But I can't erase it without killing it. There. Okay. Pretend this isn't there. All right. So what ends up happening is if you were to draw a rectangle with those dimensions, 2 by 5 by 3, right, you would land, that point would be like the diagonal of the rectangle from the origin. Does that kind of make sense? Okay. All right, that's a lot of talk for something that you'll never have to do. But anyway, it kind of helps you understand when you see these, where is it coming from? So I want you on paper to try to graph the point -2, 5, -4. Take a minute and give it a shot. Get it? Okay. So there's our second point. -2 on the x, 5 on the y, -4 on the z. Moving right along. Okay, name that point. This point is located 7 units in front of the xz plane, 2 units to the left of the xz plane, and 1 unit below the xy plane. What the heck are the yz, xz, and xy planes? All right, so if you look, here's your, wow, it's really messy. All right, so if this is your x-axis and this is your y-axis, the xy plane, and I don't know if you can see it very well in the picture, it's the plane that contains the x-axis and the y-axis. A plane is a flat surface. I kind of think of a plane as like a sheet of paper, right? So if you look at your x-axis and y-axis, the plane here, like this, if I set a sheet of paper that had those 2 axes in it, that would be called the xy plane. So the plane that contains the y and the z, this right here, that's the yz, and then the x and the z, that's the xz plane. Does that make sense? The hardest thing about teaching Calc 3 is like getting you all to understand everything visually. There just aren't enough aids to help everything. But anyway, so those are the planes. And by the way, I know I need to explain this to you, and I'm pretty sure I don't have a slide for it. Hang on, I'm gonna, I don't. All right, so I'm gonna talk right now. So not only do you need to know those 3 main planes, right? The planes are the planes that contain the axes, but you also need to know your new, what are no longer quadrants, they are octants. So back in all of your prior math, you had 4 quadrants, right? So if that was x, that was y, right? That is gone. So because we don't have 4 quadrants anymore, we're in space, right? So instead of 4 quadrants, we now have what are called 8 octants. Now, your first octant is where everything is positive. If like you were to, I want someone to come up here and see if they can point to which octant they think is the first octant, where all the coordinates will be positive. Who's going to volunteer? All right, Tejesh, come on up. You guys, this one over here. Tejesh says this one. What do you think? Yes or no? Why not? Because the y would be negative in this octant right here. So which one?
This is the y.
This is the red is your y. Y is positive, y is negative. So if I'm in here, I have a negative y. So how could you fix it? This guy, that's the first octant right there. And what happens is the octants, just like this is your x, this is your y. So normally they go 1, 2, 3, 4 counterclockwise. They go 1, 2, 3, 4 counterclockwise. So the first octant is where everything is positive, and they go around from there with a all positive z. So 1, 2, 3, 4. Then below 1, they start over with 5, 5, 6, 7, 8. So on the screen, this is really hard to see, and I hate it because the only octant visual I could find in the world has them rotated, and I don't like it. So I'm just going to tell you, like up here, in here, this is octant 1, 2, 3, 4, and then down here, so below the XY plane, you start 5, in the back here is 6, the one that you can't see in the back is 7, I'm not even going to draw, and then this one down here is 8. So 1, 2, 3, 4 are the top, 5, 6, 7, 8 are the bottom. All right, and again, this is not stuff you're going to be tested on. It's more stuff that you just need to know so that when we're talking about things like, oh my gosh, we were going to find the volume in the first octant, it helps if you know where the first octant is, right? That kind of a thing. So, okay. All right, good. So now that we've got that out of the way, so there is one point. I want you guys to talk quietly in your groups. There is one point that is 7 units in front of the YZ plane, 2 units to the left of the XZ plane, and 1 unit below the XY plane. See if you can figure out what that point is. Because Z is going to be your output for all of your functions. X, Y are going to be like your inputs are all going to be ordered pairs of X's and Y's, and then your Z is your output. So we want the Z to be the height so that it's the output. It's the how far up, how far down. And then, so you kind of think, and we're like getting way ahead of ourselves, but you kind of think of it as like, how high does my graph go at the point, 2, 3? I'm up here, right? So all of your input, instead of being single-digit numbers, are now ordered pairs. So it's kind of like the XY becomes the where, and then the Z becomes the how high or how low do you go. And that's how you end up getting all of your 3D graphs, right? Okay. All right. So 7, -2, -1. Part 2. Describe the point for which Z equals -3 and X times Y is greater than 0. So think about this for a minute. Z, is that a point? Is that a line, or is that a plane?
Plane.
That's a plane. Now, I tend to use little whiteboards to demonstrate planes. It's a plane that's 1, 2, 3. It's right here. So it's all the points parallel to the XY plane that pass through Z equals -3. So think of it as like any point, no matter where you are on this plane in any octant, your Z coordinate would be -3, right? So this is the plane. This is a really, really bad demo. But this is the plane, Z equals -3. So we're on the plane Z equals -3. However, we only want the parts of the plane that have a positive multiple of X times Y. So we need to only take 2 quadrants, because there are only 2 quadrants where X times Y is positive. Amal, how you doing? Good. All right, can you name one of the quadrants where X times Y is positive? Yeah, where they're both positive. And the first one's actually true. That is where x times y are both positive. But can you tell me a quadrant where x times y is positive, but your z is negative? Yeah, beautiful. That's exactly right. So it's really hard to point. So the fifth quadrant is down here because you have, so x and y, when x and y are both positive, you're going to be somewhere in here, but we want a negative z, so we're down here, right? There's one other quadrant. So, which quadrant? Are you sure? Yeah. You're right. You're right. Okay. Why? Why are all of my x times y? Why is the product of x times y positive in the sum? They're good. They're both negative, right? So you end up with a positive product. Very good.
Wait, so the y is positive to the right?
Y is positive this way, negative this way.
But why is it like when you rotate it, like isn't y positive on that side? I'm confused.
Okay.
So like if it were
So you're talking about back in the old days, like
Yeah.
2 dimensions?
uh-huh.
Okay, 2 dimensions. If x is yellow and y is red, right? This would be 2 dimensions. Don't even look at the blue. Just look at the yellow and the red, okay? All right, are you ready to follow?
Yeah.
Okay, so it goes like this. Okay, all right?
Okay.
So positive, positive.
Okay.
Positive forward, positive right, positive up. Forward, right, and up are all positive. Backwards, left, and down are all negative. Does that make sense? Okay. All right. Good. So for those of you who are watching who can't see any of that, it would be the plane
Don't say that.
z equals negative 3 in quadrants 5 and 7. If you want to write those numbers, that's fine. All right. All right. So you know what? Before we do this, let's learn distance and midpoint, and then we'll go back and do how far. All right. So distance in 3 dimensions is just like distance in 2 dimensions, except now you get a z. So your distance formula that you used to know, so change in x squared, change in y squared, now you have a change in z squared. And it's the square root of all those. It's really Pythagoras, but in 3 dimensions. So see if you can do that first example where you find the distance between those 2 points. And then, without me even teaching you the formula, I want you to see if you can find the midpoint between those 2 points. Where's my pause? Okay, so for the distance between the 2 points, you're just subtracting each corresponding letter and squaring, right? And then take the square root of the whole thing, and you get square root of 30. So now we have to find the midpoint between those 2 points. How do you find a midpoint? Michelle, how do you find a midpoint?
You add the 2 numbers together and divide by 2.
Yes, you're finding the average, right? Midpoint is the halfway, so it's the average of the x, average of the y, average of the z, right? So you just add the 2 letters together, like 4 plus 2 is 6 over 2, add the 2 y's, negative 1 over 2, add the 2 z's, 1 over 2, and then just clean it up a little bit, so you get 3, negative a half, 1/2. Does that make sense? Okay, distance, midpoint. We'll use both of these quite a bit this year. All right. So, we're doing great on time. Awesome. Okay, little bit of a fun example. So, some of these are going to be piece of cake quick, and some of these might take a little bit of work. Not crazy work, but take a minute and see if you can find all 6, and then I want all 6 on your whiteboards when you are done. Distance to the x from a point to the xy plane is the same as the what? The z value. Come on. The distance to the xz plane is the same as the y value, and the distance to the yz plane is the same as the x value. So that's kind of nice, right? Now, when you're talking about distance to the x-axis, that's a little bit trickier, right? So when you're doing the distance to the x-axis, you need here, I'm going to do this. You need perpendicular distance to the x-axis. So from the point -2, 3, 4. So what octant are we in for point -2, 3, 4?
Yeah, second. Oh, second. Yeah, second. I wanted to say axis like there. Yeah, second.
Which octant? Second. We're in the second octant. Okay, very good. All right. So we go -2, 3, 4. We're up here, right? If I want the distance to the x-axis, it's not the distance to the origin, right? That, if I'm doing distance to the origin, that's just the square root of -2 squared plus 3 squared plus 4 squared, right? But it's not. It's actually the distance this way, right? So you got to figure out what point is this right here and then find the distance between these 2 points. What point is this right here? Oh, wait, I'm on the wrong spot. X-axis, this way. Sorry. Okay, so this way. So you got to figure out what point this is. Well, quick question. If I'm on the x-axis, what is my y value? And what is my z value? 0. So it's actually, and then for, if I'm like perpendicular with this point, what's the x value going to be for this? -2. So it's really the distance from -2, 3, 4 to -2, 0, 0, right? So you're going from -2, 3, 4 to -2, 0, 0. And when you do that distance, using your Pythagorean theorem, you get 5. So well done. That took some thinking. So good thinking, right? What? Rock on. Okay, yeah. All right. Distance to the y-axis. What point would we be going to? 0, 3, 0. And our distance is root 20 or 2 root 5. I don't care. Either way. Z-axis. We're going to what point? 0, 0, 4. And our distance is root 13. All right, and that's done, and that's done. And last thing we need to know before you, oh, we still have lots of time. Look at this, it's great. You know what? Oh, here we go. So first thing we need to do is find, well, you can do either, it doesn't really matter. So you have to find the center. How do you find the center?
The midpoint.
The center is the midpoint of those 2 points. So what's the center? Tajesh, what's the center?
Center is 5, 1, 5 halves.
5, 1, and then 5 halves. Did everyone get the same center?
Yeah.
Okay, how do you find the radius? So how do you find the radius?
I use the distance formula.
Did you distance between these 2 points or like this and this point?
I did between the 2 endpoints.
The 2 endpoints and then halved it?
Yeah.
Okay. So what'd you get for distance?
Sorry, it was like 6.1.
You did it in decimal.
Wait. No. I just got my r squared. It would have been square root of 149.
It would be what?
Square root of 149.
Did you guys get square root of 149?
Wait.
Is that your radius or your full distance?
That was my full distance. I'm
That's your
sorry.
full distance.
149 over 2.
And then your so then your radius is root 149 over 2, right? Okay, so then your equation of your sphere would be x minus, you guys all just say it, 5 squared plus minus 1 squared plus z minus 5 halves squared equals 149 over 4 r squared. Good. There's, that's it. So you can't graph yet. I haven't shown you how to use your grapher program on your laptops yet, but don't worry, it will come. If you're really stuck tonight, actually I can show you in 2 seconds before the bell rings. If you really do get lost and you need to see a graph, every single laptop has what's called Grapher. You just go to search and you can type Grapher and it'll come up. It shouldn't even need to be installed. this grapher is the best program on your laptop. You pick 3D, and then say you want to graph the plane like x equals 3. Like, oh my gosh, where is x equals 3, right? So you can, you can just grab and twirl however you want. So just remember X, Y, Z, right? It will always orient X, Y, Z, but it comes with this auto rotate kind of thing, so it'll kind of spin as you go. But anyway, so this we're going to use constantly all year whenever we have to graph stuff and we need a quick visual of what it looks like. We'll be going to Grapher. All right, have a great evening, and I will see you all tomorrow. Remember your homework tonight. How do you find it? It's in WebAssign.